Okay, today we're going to talk about the square roots of variable expressions and then briefly look at solving basic square root equations. Okay, so the first thing we want to look at is we're going to ask ourselves a question. Is it true that the square root of x squared is equal to x? Recall that this symbol, okay, which is the square root symbol, names the principal or positive square root of a positive number. So whenever we see just the square root symbol and they're asking us to simplify, they're asking for just the positive or principal square root. Principal and positive are the same thing, okay? So when x is equal to -9 and I square it, that gives me positive 81. And the square root of 81, because they're asking for principal here, would be 9. So this is not always true, okay? It depends on what x was originally. So it's not always true that the square root of x squared is equal to x. If x is positive, it's true. But if it's negative, then this is what your answer would be. In either case, we know for sure that this is true, that the square root of x squared, again, they're looking for the principal square root of x squared is equal to the absolute value of x. So it doesn't matter whether x was positive or negative. If we take the absolute value, that's going to give us our principal square root. So when you are finding principal square roots of variable expressions, you must be careful to use absolute value signs when needed to ensure that your answer is positive. So let's look at some examples here. We have the square root of 196y squared. Well, the square root of 196 is 14. The square root of y squared is just y. Now, because there's nothing out here, that tells us they're looking for the principal square root, which means positive. So if y happens to be negative, this whole thing would be negative, and therefore it wouldn't be the principal square root. So we're going to put the y in absolute value symbols to guarantee that this is the principal square root. So now it doesn't matter whether y was positive or negative. If we look at our next example here, we have 36x to the 8th power. Square root of 36 is 6. And the reason why we don't worry about the signs when it's just a number is because we know it's the principal, and so we're just looking for the positive. So even though the square root of 196 could also be negative 14, we didn't worry about that because it's a principal. Same with this one. We're only worried about the principal square root. So even though theoretically the square root of 36 could also be negative 6, we don't worry about that. The square root of x to the 8th power is x to the 4th power because we just take the exponent and divide it in half. If you look at it this way, when we multiply the bases, we add the exponents, okay? This, it doesn't matter whether x is positive or negative because any number that's raised to an even exponent is going to be positive. So this one we don't have to worry about putting in an absolute value sign. Here we have an expression, and this happens to be a perfect square trinomial, and we're going to see a lot of these. So if I were to factor it, I would get that. Well, then I'm going to take the square root of that. Well, the square root of m minus 3 squared is m minus 3. Now again, because we're looking for the principal square root, I'm going to put the whole thing in absolute value. So whatever this was, it could have been negative, could have been positive, and then I squared it. Since I'm looking for this positive square root, I put the whole thing, the whole expression, in the absolute value sign. If we look at our fourth example here, notice that my a is raised to an odd number exponent. Okay, so think about that. Suppose a was -2, and I raised it to the 3rd power. That would be -2 times -2 times -2, which would be -8. We can't take the square root of a negative number. So the fact that a to the 3rd is underneath the radical sign tells me that a must be positive. Okay, a has to be positive, otherwise we can't do this. So what I do then is I go through and I simplify. That's 9 times 2. This I'm going to say a squared times a, okay, because I can't take the square root of an odd exponent. So this becomes 3 square root of 2 times a square root of a. If I put everything in the correct order, multiply my exponents, multiply my square roots there, I get that. Again, I don't have to use the absolute value sign because I already know that a has to be positive. Okay, so if I start off with a negative exponent, I don't have to worry about absolute value. If my solution, my variable, has an even exponent greater than 2, actually 2 is fine as well. An even exponent, I don't have to worry about it. It's only when I end up with an odd exponent, that's a 1, where I started off with an even and I ended up with an odd, then I have to use the absolute value. Or if I have an expression where m could be anything, I have to use the absolute value. All right, let's look at solving a basic square root equation. So in the past, meaning like a couple months ago, we would solve this equation by factoring. So we would get 9x squared minus 64 equals 0. This is the difference of two squares, so we would factor it like this. 3x minus 8, 3x plus 8. We would set each factor equal to 0. And then we would say, well, x is equal to 8/3, and x is equal to negative 8/3. So we'll write it out like this, plus or minus 8/3. Okay, so you would have to know how to factor. You might have to do X box. You might have to do slide divide bottoms up. We're not going to do that anymore. Now we know that we can solve it using square roots. So what I want to do is I want to get the variable that's being squared by itself. So I need to get the x squared by itself. So I'm going to divide both sides by 9, and I get x squared equals 64 over 9. 64 and 9 both happen to be perfect squares, which is wonderful. So I can take the square root of both sides without having to change anything. X is equal to, now because it's an equation, we're looking for both roots. So I just put plus or minus, and it's going to be 8/3. So the same answer, it was just a little bit quicker. Okay, didn't have to worry about doing the factoring. All right. Here's a property of square roots of equal numbers. For any real property R and S, R squared equals S squared if and only if R equals S or R equals the opposite of S. Basically what this means, if I have two numbers that are the same, they're going to have the same square. If I have two numbers that are opposites, they're going to have the same square. So for example, if say R was 4 and S was 4, they would both have a square of 16. If R was 4 and S was negative 4, they would both have a square of 16. Okay, so that's all that that's saying. All right, let's look at our proof. So we have the square root of 400 z to the 6th power. The square root of 400 is 20. The square root of z to the 6th power is z to the 3rd power. Because I started off with an even exponent and I ended up with a negative, I need to put this in parentheses, or not parentheses, in absolute value signs, because z could potentially be negative, which would make the whole thing negative, and they're looking for the principal square root. Okay, if I look at my next one, I have 162y to the 12th power. 162 is not a perfect square, but it is 81 times 2. Square root of 81 is 9. The square root of y to the 12th is y to the 6th. Put it in the correct order. It should go coefficient, variable, and then radical. I don't need to put y to the 6th in absolute value signs because it doesn't matter whether y is positive or negative. If I raise it to an even exponent, it's going to give me a positive number. If I look at this expression, this is a perfect square trinomial. 10 plus n, the whole thing squared. If I take the square root of that, it's 10 plus n. Because n could be negative, suppose n was negative 15, this whole thing would be negative 5. We're looking for the principal, so I put the whole thing in absolute value signs. The last proof, I have my my square root equation. Instead of factoring it, I'm just going to solve for r squared. So I'm going to have 45r squared is equal to 500. Divide both sides by 45. R squared is equal to 500 over 45. Now I'm going to take the square root of each side, but 500 over 45, those are not perfect squares. So I'm going to see if I can simplify it. And I'm going to divide both of these by 5, and that gives me 100 over 9. Well, 109 are both perfect squares, so that's good. So I'm going to leave it like that, take the square root of both sides. That's going to give me r. Because this is an equation, I'm looking for both roots, and it's going to be 10 over 3.